Hello everyone, and in this video we're looking at an I's and J's question, and I've picked this question because it's got a bit in part B that I know from past experience students do find a bit tricky, especially the northeast kind of idea where they tell you it's going in a certain velocity, and you have to use that. Okay, so it says a particle P moves with a constant acceleration. At time t equals 0, the particle is at O and is moving with a velocity of 2I minus 3j meters per second. At time t equals 2 seconds, the particle is at point A and it's moving with position vector 7I minus 10j. Show that the magnitude of the acceleration of P is 2.5 meters per second squared. Okay, now the first thing is it's telling us in this question that this is a constant acceleration. And the fact that it's constant acceleration means it's going to be a SUVAT. Because often students with this kind of question wonder, is it one of those where you have to integrate or differentiate? Because that often happens with the I's and J's. But because they've mentioned constant acceleration, we know we can approach this with a SUVAT. So we should always start off by writing down S, U, V, A, and T. And let's see what we got. We've got it's moving at time t equals 0. It has a velocity of 2I minus 3j. So 2I minus 3j is our initial velocity. Then at time t equals 2 seconds, it's at the position 7I minus 10j. So we have a displacement 7I minus 10j. We're asked to find the acceleration. And when we write down SUVAT, there's always one that we don't need to know. So our appropriate SUVAT that doesn't involve V is going to be S equals UT add half AT squared. So let's write that down and then substitute in. Our S is 7I minus 10j. Our U is 2I minus 3j. Our time is 2 seconds. The acceleration we're trying to find, and again, time is 2 seconds. So we can expand this now. 7I minus 10j is equal to 4I minus 6j plus 4 over 2a. And then we can now take everything over one side. So we're going to have 3I when I take that over one side. And we're going to have 3I, and then we're going to take that over the other side. So we're going to have minus 4j is equal to 2 times the acceleration. And then we're now going to divide by 2. So we're going to have 3 over 2I minus 2j is our acceleration. Okay, perfect. So we found our acceleration, and now we need to show that it has a magnitude of 2.5. So if we take the magnitude of this acceleration, that's going to be 3 over 2 squared plus minus 2 squared, add them together and square root it. And that's going to give us, if we turn it to a decimal, 2.25, because that's 1.5 squared plus 4 square rooted, which is the square root of 6.25, which is a square number. So that's going to square root into, that's going to square root into 2.5 will be our answer. So there we go. We have the first part done. Our acceleration is equal to 2.5 meters per second squared. Okay, so that was not too bad. Just remember to use a SUVAT there because it says constant acceleration. Quite a nice 4 marks there for part A. Let's have a look at part B. Now it says so it's the particle started off at the origin, it got to A, and now it's moving on to B. Okay. And it says at the instant when the particle leaves the point A, the acceleration now changes so that it now has a constant acceleration of 4i plus 8.8j. At the instant when it reaches the point B, the direction of motion is northeast. Okay, so when it reaches this point B, at the second that it's there, it's going in this kind of like northeasterly direction. That's the direction of travel at the point that it reaches the point B, and we're going to be using that in a moment. So for this second part of the question, it would be useful to us to know how fast was the particle traveling at the point that it reached A. So we need to do a SUVAT to help us know how fast it was going when it reached A. So SUVAT. We're dealing with our original acceleration because from 0 to A, its acceleration hadn't changed yet. So 1.5 I minus 2j. The time it took to get there was 2 seconds. We know that the initial velocity was 2I minus 3j at that point. We're not worried about the displacement. We're trying to calculate how fast it was going. So that's going to be just the SUVAT v equals u plus at. So we have our v, which we're trying to find, is equal to our u, which is 2I minus 3j, plus our acceleration, which is 1.5I minus 2j, times by our time, which is 2. Okay, so that's how we're going to find our velocity. So what's that going to give us? That is going to give us 2 add 3 is going to be 5I, and then we're going to have minus 3 minus 4 is going to be minus 7j. So that's the velocity as it reaches A. Okay, now we need to think about, that's meters per second. Now we need to think about moving from A to B. Okay, so now we're going from A to B. We've got a new acceleration. Let's write down our SUVAT again. We now know the new acceleration is 4I plus 8.8j. The time is what we're trying to find in this one. Find the time it takes to travel from A to B. We know, what else do we know? We know that our initial velocity in this case is 5I minus 7j, because that's the final velocity from before. We're not worried about the displacement, and we're trying to find the velocity. So it's going to be v equals u plus at. Notice here that apparently we've got too many unknowns. We've apparently got one equation with two unknowns. And the reason that we're able to solve this is by using the idea in a moment of equating the i's and j's, but we'll discuss that in just a second. Okay, so our v we're trying to find is our u, which is 5I minus 7j, plus our acceleration, which is 4I plus 8.8j times by t. So I'm going to expand that now. Plus 4ti plus 8.8tj. And then I'm going to gather together my i's and my j's. So 5 plus 4ti. And then I'm going to have plus, I'm going to call it 8.8t minus 7j. So I've just gathered together the I component and the j component. Now here's the crux, the most important idea in this question. So they're telling us that it's moving in a northeasterly direction at the point when it reaches B. Now, if it's moving northeast, it means that at that moment, the I and the j components must be equal to each other. That's the key idea. Because it's lying along the line y equals x. The line y equals x corresponds to northeast. So that means we can put the I component equal to the j component. And that's how we're able to solve this, even though we're apparently, missing, not having enough variables. It's the fact that we're able to equate these means that we can, in fact, solve it. Okay, so what's that going to give us? That's going to give us 12 is equal to 4.8t, and therefore t is going to equal 12 over 4.8, and when we work that out, that is 2.5 seconds, which is our correct final answer. So super important idea there. I would also, whilst I'm on this topic, I would also point out that there are other variants of this question. So sometimes they'll tell you, so let's imagine in this one they said it's going northeast, okay? If they'd have said that the particle was going southwest, so let's have a look, north, east, south, and west. If they'd have said it was going southwest, we would have used exactly the same approach, because it would still lie along the line y equals x. So if this question had said southwest, we would still have equated the i's and j's. Now, another variant of this question is where they say, okay, let's imagine it's going in a southeasterly direction. Okay, if they say it's going in a southeasterly direction, what you do is, because it's lying along the line y equals minus x, is you basically just set I equal to minus j, or minus I equals j. You make one of them negative, yeah? So that's what we would do if the question told us it was traveling in a southeasterly direction. And then finally, they sometimes say it's going northwest, okay? And if it was going northwest, or if it was going southeast, we would basically take the I component and put it equal to negative the j component, or vice versa. And the logic, the reason for that is because it would be lying along the line y equals minus x. So a very, very popular kind of question, and I know one that students do get quite confused with. I hope you found that helpful, and I will see you in the next video.